Yeah, I'm Jessica, and together with Kelvin, we'll be presenting to you our solution, Neptune Ocean. So we are from Firemark Labs Singapore. Kelvin is based in Sydney, and I'm based in Singapore. Moving on, here is a quick introduction about the team. Thanks for the beautiful introduction to us earlier. I have been leading the product and UX for Neptune Ocean and have spent some time down in Sydney interviewing the various lifeguards, life-saving association and stakeholders, and speaking to the lifeguards and lifesavers on the ground. On the call with me today, I have Kelvin also. As mentioned, he is an ex-lifeguard and he's now a machine learning engineer, and his experience has allowed him to contribute directly to building the Neptune Ocean model. So quick stats over here. I'm probably preaching to the converted. We all know the dangers of the ocean. And over here, you can see the article. It's very sad to see where a daughter has to watch her mother drown from the beach while they're on a holiday. And these are the kind of incidents that we are all hoping to work towards preventing and to try to increase the victim's chances of survival. So very quick overview of what we're trying to solve and our solution. If you have been sitting through the very first session in the morning, you'll know that having a key problem statement that you are solving is very important to any lifeguard or life-saving association. So after going through research papers and from interviewing lifeguards and lifesavers, we had determined that coastal drowning problems happen usually on loosely patrolled, unpatrolled beaches and during off-shift hours where no rescue team is available on site. Rips and rock fishing are found to be the main contributors of this. So what our Neptune Ocean solution aims to do is use computer vision on surveillance footage so that we can feed a command center beach views that demand their attention. This will enable better and faster decision making, especially when it comes to resource allocation for life-saving purposes. And the reason why we chose to create a solution targeted at the command center instead of putting it in the hands of a lifeguard or lifesaver at a beach is very simple. Because we found that through our interviews with them, we realized that lifeguards and lifesavers do not want to be distracted by their current duties. They need to stay vigilant, eyes on the beach, rather than looking at a video footage or a piece of technology on their hand. I know this sounds a bit abstract, so I'll illustrate with our use case on the next slide. So on the left here, you can see a command center view. To provide some context, Neptune Ocean focus has been mainly centered around Australia's Surf Command Center. This is commonly known as SurfComs. SurfComs sits at the state level that looks after about between 30 to 50 beaches. And you can see a snapshot of just the sheer number of beach views that is bombarding an operator at any one time. It is then pretty difficult for an operator to spot, let's say, a distressed swimmer in a timely manner. So this is where Neptune Ocean comes in. On the right-hand view, you can see that our solution exists as a computer vision layer that is applied to existing beach views. The result is that cameras are now ranked in order of their risk score. SurfCom operators' attention can then be drawn to beaches with the highest risk score. Over here, we have a quick demo to show. Just a note that this is a recording of how Neptune Ocean works. And for demonstration purposes, we have used a single view of Manly across different time periods. You can see the large number 0, 1, 2, 3, 4, 5. These are the camera numbers. So as you can see, our model is applied on top of surveillance footage, and it's triaging the camera views in terms of their risk score. Bounding boxes will indicate where people are approaching these areas of high water risk. With this alert, we are hoping to inform the command center staff in a timely manner when danger is about to happen or is happening. So I'll switch back here. Next up, I'll hand off the solution section to Kelvin.
Yeah. Hey everyone, I think the video might not have come through, but there was a running simulation before. just picture it moving around and the camera views shuffling as it gets triaged. So basically, we currently have 2 machine learning models, one focused on the water risk and one focused on the people risk. The next slide, please, Jess. Okay, so for the water risk, basically what we're trying to do here is evaluate how strong the rips are going to be. So think of this as maybe what you'd like to know before you leave the house. It's not localized, it's just based on the swell and tidal data. And so in the top right there, we can see an example where there is significant swell and a fast going out tide, and you can actually see the discolored water and the ripples on the surface. And then another example where it would generate a very low score. The next thing we do is we try to find the people, but also we assign them different varying levels of risk based on the classification. So if they're not in the water, we get a 0 weighting. If they're on a surfboard, they will get a much reduced weighting compared to a swimmer because they have flotation. And then the highest risk will be a person fully submerged with basically just their head poking out of the water. And the next up, please, Jess. So basically what we do is we need to define a risk profile for the scene. So due to just restraints with getting enough high quality footage, we haven't been able to automatically generate this. So basically we define using user annotations where the risky areas are, and then that'll automatically generate a heat map. We then get where the people risk detections are and overlay them on top of each other. And then we also fuse this with the water risk score, because if there's normally a rip in a certain spot, but the waves are like on the previous slide where it's like a lake, it's not going to be a particularly high risk. And then we perform a series of operations and try find, we're actually most interested in the local maxima. So if there are more points where people are close to dangerous areas in a high risk zone, it'll generate a much higher fusion risk score. And then we compare these fusion risk scores to other historical predictions to normalize them, because that fusion risk score has no real interpretable value. It's all relative. And then that way we can rank the camera views and then give a score between 1 and 100 to the SurfCom operator. So yeah, here's an example. It's an older model for the people detection, so you might get some false positives by the trees there, but we've since masked that out. But basically you can see how each of the models sort of interact with each other, and then the top right, it provides the final fuse score. Hopefully it's not running too quickly because that's spaced out of a very long time period, so it's probably just flickering. But that's just an example of how it all works together. And then in terms of evaluation, because I've had a lot of input in the labeling, what we do for unbiased feedback is we get lifesavers and lifeguards to provide us some feedback by labeling videos and comparing them to each other. And so we've built a tool to do this. They'll watch video clips and then compare them to each other. And then we'll compare what the comparisons that our model outputted, and then we'll use that to evaluate and provide a score for how our model's doing for the fusion risk.
Yeah, finally, in conclusion, I'd like to share more about what we're looking up next for Neptune Ocean. We're hoping to secure a trial with SurfCom, and with this trial, like what Kelvin mentioned earlier, we do need more data injected, and more importantly, diverse data, so that we can continue making the model more robust and scalable. And eventually, we hope to be able to commercialize Neptune Ocean and help reduce drowning deaths across the world. Of course, we are open for collaboration opportunities and would love to partner up with others to accelerate our collective progress. So feel free to reach out to me or Kelvin. My email is here on the screen. Thank you.